Arithmetic Progression. Illustration 1. See the pictures. First 3 matchstick will be there. Then the next diagram, 2 more matchsticks. So here it is 3, here it is 5, here it is 7, isn't it? 3, 4, 5, 6, 7. Here it is 9. So in this matchsticks, how many matchsticks are required for each figure? 2 more, isn't it? So first one is 3, then 5, 7 and 9. Can we find the difference between successive numbers? What is the difference between the first diagram and the second diagram? 2 matchsticks only. The difference between second and third, again 2 matchstick only. Third and fourth, again 2 matchstick only. So when you are subtracting 5 minus 3, you get 2. 7 minus 5, you get 2. And 9 minus 7, you get 2. That difference is called common difference. Therefore, the difference between successive number is, here it is always 2. See the definition. Let A and D be real numbers. Then the numbers of the form A plus D, A plus 2D, A plus 3D, A plus 4D, etc. is said to form arithmetic progression denoted by AP. Arithmetic progression is denoted by AP. The number A is called first term and D is called a common difference. That is the definition of arithmetic progression. First term is A, then the second term A plus D. One difference will be added. Again that same difference is added. So A plus 2D, A plus 3D, A plus 4D, etc. A is the first term and D is the common difference. Then see the note. The difference between any two consecutive term of AP is always constant. The difference is always constant. That constant value is called a common difference. If there are finite number of terms in an AP, then it is called a finite arithmetic progression. If there are infinitely many terms in an AP, then it is called a infinite arithmetic progression. Now we can study the terms and the common difference of an AP. Terms means we can denote it as T1, T2, T3. Each member of the arithmetic progression, that is called terms. The first term, second term, third term and fourth term. So first term is A. We can write it as A plus 1 minus 1 into D, because the common difference here it is 0, isn't it? The first term is A only. We can write in this way. Then T2 A plus D. A plus D means A plus 2 minus 1 into D. 2 minus 1 is 1. So you get A plus D. Then T3 A plus 2D. A plus 2D can be written as A plus 3 minus 1 into D, because the third term, so 3 minus 1. Second term, so 2 minus 1. First term, so 1 minus 1. So fourth term, similarly we can write it as A plus 4 minus 1 into D, that is A plus 3D. So from this we have to find out the nth term. Nth term. What is nth term? Tn. Tn is equal to A plus n minus 1 into D. So we have to study this nth term as a formula. It is very useful for doing problems in this section. So in an AP, nth term is Tn is equal to a plus n minus 1 into d. Here a is the first term and d is the common difference. Then in general, to find the common difference of an AP, we should subtract the first term from the second term from to the third term, and so on. So we have to subtract. First term is a, second term is a plus d. For finding the common difference, you should subtract t1 from t2. So t2 minus t1 is equal to, t2 is a plus d, t1 is a, so minus a. So a and minus a gets 0, then you get d. Similarly, we know t2 is a plus d and t3 is a plus 2d. When subtracting t3 minus t2, what do you get? A plus 2d minus a plus d. When you are changing the sign inside, a and minus a get cancelled. 2d minus d, you get d. So when subtracting the terms, we get the common difference. Generally, we can write it as d equal to tn minus 1, tn, nth term, minus the previous term. Okay, tn minus 1. Now one progress check will be there. We can fill in the blanks. The difference between any two consecutive terms of an AP is constant. If A and D are the first term and a common difference of an AP, then what is eighth term? Eighth term means A plus 7 into D. A plus 8 minus 1 into D. 8 minus 1 is 7. So A plus 7D. If Tn is the nth term of AP, then T2n minus Tn is A, and T2n means A plus 2n minus 1 into D, minus Tn is A plus n minus 1 into D. When you are cancelling this A and 2n D minus nd, so when you are simplifying, you get nd. Then we see this exercise 2.23. Check whether the following sequences are in AP or not. See this: x plus 2, 2x plus 3, 3x plus 4, etc. We have to check the sequence is an AP. How to check the sequence is an AP? We have to check the common difference. T2 minus T1, T3 minus T2. If they are same, we say that they are in arithmetic progression. So T2 minus T1 first you take. So you get 2x plus 3 minus x plus 2. When you are changing the sign inside, you get 2x plus 3 minus x minus 2. So 2x minus x, you get x. And 3 minus 2, you get 1. So you get x plus 1. Similarly, T3 minus T2. T3 is 3x plus 4 minus 2x plus 3. When you change the sign inside, you get 3x plus 4 minus 2x minus 3. So what is 3x minus 2x? X. And 4 minus 3, you get 1. So here also you get x plus 1. So T2 minus T1 is equal to T3 minus T2. So the difference between consecutive terms are equal. Therefore, the given sequence are in AP. Okay. Then the next sum, 2, 4, 8, 16. 2, 4, 8, 16. Here the first term is 2, second term 4, third term 8, and fourth term 16. We check the common difference. So first T2 minus T1, that is 4 minus 2, you get 2. T3 minus T2, that is T3 is 8 minus 4. 8 minus 4, you get 4. Then T4 minus T3, 16 minus 8, you get 8. Here 2, 4 and 8. It is not same. The difference between consecutive terms are not equal. So, it is not an AP. The given sequence is not an AP. Then the next question. 3 root 2, 5 root 2, 7 root 2 and 9 root 2. Here uh, four terms are given, isn't it? We have to find out the difference. T2 minus T1. That is 5 root 2 minus 3 root 2. You get 5 minus 3, 2. So 2 root 2. Similarly, T3 minus T2, 7 root 2 minus 5 root 2. 7 minus 5 is 2. So 2 root 2. T4 minus T3, 9 root 2 minus 7 root 2. Here 9 minus 7 is 2. So 2 root 2. Here the difference is constant. Same for all the terms. All the differences are same. So difference between the consecutive terms are equal. Therefore the given sequence are in AP. Then the next example 2.24. Write an AP whose first term is 20 and a common difference is 8. Here the first term is given 20, common difference is 8. We have to write the AP. First term 20, common difference D is equal to 8. We know the general form of AP, A plus D, A plus 2D, A plus 3D, etc. Substitute the values. First A, 20, A plus D, that is 20 plus 8. A plus 2D means 20 plus 2 into 8. A plus 3D means 20 plus 3 into 8, etc. So when you are adding, you get 20, 28. Here 8 2s are 16. 16 plus 20, 36. Like that 8 3s are 24. 24 plus 20, 44, etc. This is the AP whose first term is 20 and common difference is 8. Then the next question, example 2.25. Find the 15th, 24th and nth term of an AP given by 3, 15, 27, 39, etc. Here given AP is 3, 15, 27, 39, etc. So first term we can write it as A is equal to 3. Common difference, that is T2 minus T1. Here it is given as AP. So simply you have to subtract two consecutive terms, T2 minus T1, that is 15 minus 3, that is 12. So what is nth term? Nth term is Tn is equal to A plus n minus 1 into D. We have to substitute the value of A and D. Before that we have to find out 15th term. 15th term means T15, that is you have to substitute the value of A and D. So what do you get? A is 3, n minus 1, that is 15 minus 1 into D is 12. Common difference is 12. When you are simplifying, 3 plus 15 minus 1, you get 14 plus 14 into 12. 14 into 12, when you have to multiply, 168. When you are adding, you get 171. Like that, 24th term. 24th term is T24 is equal to A plus 24 minus 1 into D. Substitute the value of A and D. So 3 plus 24 minus 1, it is 23 and D value is 12. Then first you have to multiply 23 into 12. Multiplication is first priority. So you get 276. When you are adding with 3, you get 279 is the 24th term. Then nth term is you have to substitute the value of A and D. A is 3 and D is 12. So multiply inside with 12. So you get 3 plus 12n minus 12. We can simplify 3 and minus 12. So you get 12n minus 9. minus 12, you have to subtract 3, so you get minus 9. That is the nth term of the given sequence. Thank you.